Good afternoon, everyone. Welcome to the CMU Portugal session of the Ciência meeting. We have the pleasure to have several representatives of very interesting research projects that are going on in the context of the CMU Portugal program. And to frame the program, we will start by presenting a short video about the CMU Portugal partnership before I present the individual speakers.
If technology had an identity, it would have ours. If technology had a place, it would be right next to us. If innovation had a trademark, it would be Carnegie Mellon Portugal. First, let's forget the ocean between us. This is a partnership that brings together the know-how of Carnegie Mellon University, a world-class institution from the US, with the experience of the best academic and industrial institutions in Portugal. Since its foundation in 2006 by Fundação para a Ciência e Tecnologia, CMU Portugal mission has been to join forces and place Portugal at the forefront of education, research and innovation in information and communication technologies. So far, the task has had nothing but success. Why? Because we are focused on exploring new research frontiers in areas such as computer science, electrical and computer engineering, public policy, human-computer interaction, software engineering, robotics, and language technologies. Our overarching mission is to foster industry-science relationships as agents of change, focusing on education and research for social and economic impact. Here's how we've been achieving it. Through dual-degree PhD diplomas between Portuguese universities and CMU, and supporting mobility programs to give Portuguese researchers and students the opportunity to visit CMU and establish the ground for new research collaborations. Research is a keystone of our partnership, and we are strongly committed to supporting groundbreaking projects in ICT, fostering interdisciplinary collaboration between industry and academia. Throughout the years, we have financially supported already over 72 collaborative projects. Recently, the most ambitious call under the program of the CMU Portugal. For the first time, 10 research projects are led by Portuguese companies, representing a strong public and private financial commitment to foster the cooperation between researchers from Portugal and CMU with national companies, promoting innovation and technology development for a global market. CMU Portugal has also been a hub for entrepreneurial initiatives, with 12 startups launched or facilitated by our activities. Together, they contributed to over $200 million of international investment, which allowed the creation of more than 1,000 qualified jobs. Most of all, we are proud of having built a strong research community that contributed effectively to an impressive number of publications, registered patents, and successful PhDs and master's theses. But the best is yet to come with new research projects and initiatives, connecting companies and academia on both sides of the Atlantic. This collaboration will keep on contributing to thrive in the innovation ecosystem. One thing is guaranteed. We will keep doing everything in our reach to bring technology into people's lives for an even brighter future.
Thank you. So I forgot to introduce myself. My name is Rodrigo Miragaia Rodrigues. I am the co-director of the CMU Portugal program in Portugal. The other co-director is my colleague Nuno Nunes, who joins us online. And on the CMU side, the other director is Professor José Fonseca de Moura. I'm going to give you a short presentation about the CMU Portugal program. The program has been in place for well over a decade. It has proceeded in a series of stages. We are now entering the third stage. The first two stages were, next slide please, yeah. The first two stages were in approximately 5 years each. And in this third stage, our goal is to create an innovation ecosystem with high-tech companies and world-class research to develop knowledge in the area of ICT, and in particular by developing the data economy and trying to help these highly innovative companies extract value from their data. Next slide, please. The program has essentially two main pillars. One of them is talent development. In that respect, we are offering several, next slide please. We're offering several types of programs. We have dual degree PhD programs where students spend about half of their doctorate studies at CMU and the other half in a Portuguese university, and they have co-advisors in both locations. We're also developing two advanced training programs for professionals, one in data science and the other in user experience. This is something that we hope can be ready within the next few months. We also have mobility programs that allow students from Portugal to spend a period at Carnegie Mellon, and also for faculty and researchers to spend their a period in Carnegie Mellon, for instance, in their sabbatical year. Right now, we have an ongoing call for our dual degree PhD program. So any student can, in the areas of ICT, can apply, and in this program, the students, after they complete their PhD, they are awarded degrees both from a Portuguese university and also from a counterpart department at Carnegie Mellon. And we have agreements ongoing with a variety of different degrees at Carnegie Mellon and different departments at Carnegie Mellon, ranging from computer science, electrical engineering, engineering and public policy, and other areas. Next. The other main pillar of the program is knowledge creation, and here we have funded a series of research projects throughout the years. And in this long list, you'll notice that we have not only a variety of different types of projects. Some of them are more applied, others are more blue sky, and also with a variety of durations and different types of research being conducted. The focus of this particular session is on a set of large-scale collaborative research projects that have started this year. And in this call, we have funded 12 projects with a total investment of 24 million euro, of which 4.3 correspond to private investment and 6 million correspond to the CMU investment. And of these 12 large-scale collaborative research projects, we have a series of companies that are involved with the universities, with the researchers, both at Portuguese universities and at Carnegie Mellon. And as you can see by the list of industry promoters and co-promoters, we have a series of highly innovative companies that really invest in knowledge and in research and to develop cutting-edge products and to be on the forefront of their areas. These projects are in collaboration, like I mentioned, with Portuguese universities and with Carnegie Mellon, and we are also pleased to have a variety of departments involved in these collaborations. We have a total of 8 Carnegie Mellon departments involved in these projects, and with 17 different research institutions in Portugal also involved in various different locations of the country, corresponding to those institutions. Next. Today we'll be hearing about 3 different projects in the area of healthcare. We believe that this is a strategically important area because it is an area that has a very important interface between information and communication technologies and their own research. And we will be hearing, and I will present you later, 3 different projects, 3 key people involved with these projects. The projects are called Intelligent Care, TAMI, and WOW. And next slide, and that's it for now. So next, what I will do is I will ask if Nunes is online, if he wants to say a few words before I present the speakers.
Thank you, Rodrigo. I'm not sure if you can hear me
Yes,
in the
we
room.
can. Yep.
Okay, thank you, Rodrigo. I'm sorry I cannot be there due to problems with getting back to Lisbon. I'd just like to congratulate everybody for all of the effort, all of the students, all of the researchers and the projects and the companies involved, and hope for a great session that I will be trying to attend if my plane doesn't start. Thank you very much again, and apologies for not being there.
Okay, thank you, Nuno. So I will then move to introduce the speakers. Let me start by thanking all of the speakers. 2 of them are here with us today, and the other 2 are online. And I'll introduce them one by one before they do a short presentation of their own involvement with the program and projects they are leading. So I will start by introducing my colleague from CMU, Carmel Majidi. Carmel is the Clarence H. Adamson Professor of Mechanical Engineering, and he has a long history of collaboration with the Carnegie Mellon Portugal project. And I think he's going to tell us a little bit about how much he has benefited from that collaboration. So thank you again, Carmel, and the floor is yours.
Thank you very much. It's a pleasure to present to you, and I've benefited immensely from this program. So I'm very eager to share the work that I've done in collaboration with my colleagues at the University of Coimbra in ISR on work that we've been doing on soft and stretchable electronics for applications in wearable health monitoring in medicine. And for the WOW project that you'll see towards the end of this the meeting, a lot of the work that we plan to do in collaboration with the rest of the WOW team will build on some of this work. So soft electronics for wearable computing is a very hot area of research. There's been really tremendous progress over the past 10 or so years on developing sticker-like electronics that can adhere to the body and be used for all sorts of different sensing modalities. And these sticker architectures have a variety of different material compositions and designs. In terms of emerging applications going beyond healthcare and physiological monitoring, these architectures also have application in haptics, and in particular, they have the potential to make haptics thinner, lighter, softer, and more compatible with the human body. So also a very exciting direction of research. And also, increasingly, there's been interest in using these soft electronics for energy harvesting, in particular, placing various types of energy harvesting transducers or generators on different parts of the body and using that to generate electricity from body heat, motion, and friction. And this is another area that my group has been involved with and also represents another exciting thrust in this field of wearable electronics. Now, in all these cases, there is an important design challenge, which is how do we get soft materials that are compatible with the human body and engineer them in ways that they can exhibit functionalities that we typically associate with much more rigid electronic materials. So we want to get sensing, electrical circuitry, computing elements for signal processing, and we want to package this in a way that the sticker or that wearable device has the same elasticity and the same compliance as our natural biological tissue. And so this represents a really important challenge in engineering. I call this soft matter engineering because it involves incorporation of soft materials. closely tied to this is the challenge of soft materials integration. With most of these implementations that we've been exploring in our collaborative efforts with our colleagues in Portugal, we've been using a combination of soft materials and also rigid microelectronic components. So the soft materials function as a carrier medium. It also functions as highly stretchable and soft electronic circuit wiring to create interconnects between these embedded chips. And the chips are necessary for various sensing modalities along with signal processing, power regulation, and also wireless communication. Ultimately, though, the overall package system should be thin, it should be lightweight, and it should be soft and elastic so it can be compatible with the human body and remain functional without resisting natural motion. Early in my research, before our collaboration through CMU Portugal really took off, a lot of our early work was on serpentine electronics. And this really built on research from other groups at Princeton and University of Illinois and Northwestern on creating stretchable electronics using conventional electronic materials like copper and gold, but patterning them in ways that they have this stretchable functionality. So you can see in the top left and to some extent in the top right images, the copper wiring used to connect all of these surface mounted electronic components have this serpentine type shape, and that allows these circuits to bend and also stretch to some extent. Here's a video of a more recent implementation that shows how these circuits are incorporated into these wireless stickers. I'll let the video play out here, but you can see the layup where we have a fabric, we have the skin adhesive at the top, and we use laser micromachining to cut the copper circuitry, these traces, to form these electrical interconnects between these surface mounted components. So for us, this had represented the state of the art of what we could achieve with soft and wireless electronics that you could adhere to the body and use for physiological monitoring. However, in a minute, I'll talk about some of the fundamental limitations of this approach. As a prototyping method, and as for making these kind of one-off implementations, it's a good enough solution. As you can see here, we can, within a few hours, use rapid prototyping to create this body-mounted sensor for monitoring knee motion. The serpentine shape of the wiring allows for fairly robust functionality. We can stretch these to about 50–60% strain before the digital electronics fail due to mechanical rupture. Here's just a few examples of various types of sensing modalities that we can achieve with these serpentine electronic circuits. Now, I mentioned that these do have limitations. One limitation is that manufacturing of these can be fairly intensive. In a lot of cases, if we want to scale this down, we to kind of microscale circuit architectures will require a clean room fabrication. And another issue, as you can see on the bottom right, is that we get delamination between those rigid copper interconnects and the surrounding soft rubber substrate. So a way to overcome those fundamental challenges with internal mechanical failure and delamination of those serpentine circuits is to replace the copper with conductive elastomers. And typically, these elastomers are composed of a either silver or carbon filler that's embedded within a soft rubber matrix. And this allows for electrical percolation and electrical connectivity. And this is what we started with in our collaboration with ISR at University of Coimbra. So working with Anaval Almeida and Mahmoud Tavakoli. This is Mahmoud's lab on the left here. And this has been an incredibly fruitful collaboration. So I want to spend the next few slides talking about the progress that we've made developing soft electronics in this collaborative effort. Now, we started by using the more conventional technique of carbon-filled elastomer composites. So these are soft silicone rubbers that have a very high concentration of carbon powder. The carbon itself is electrically conductive. So by having a very high concentration, we can form electrically conductive pathways within the rubber. And this has been very effective for creating all sorts of resistive and capacitive pressure and strain sensors that we've been able to incorporate into a robotic hand prosthetic that Mahmoud's lab has developed. And this has led to several publications that we prepared in the early stages of our collaboration. Since, though, we've largely shifted to liquid metal as a soft conductive material. As you can see here in this video, if we put a microfluidic trace of liquid metal within a strip of soft silicone rubber, we can get highly stretchable circuit wiring. And this overcomes a lot of the challenges with the serpentine copper traces, or for that matter, these particle-filled elastomers. We have very high metallic conductivity, but because the conductor is fluidic, it can deform almost infinitely as the surrounding rubber is stretched. And so I'll just very briefly show some of the work more recently that we've been doing with Mahmoud's lab in incorporating these liquid metal electronics into soft bioelectronic stickers. The first effort with liquid metal involved the creation of these biphasic circuits. And this was a discovery made in Mahmoud's group. They were experimenting with printing silver ink using just a standard desktop inkjet printer. And then they would coat it with this liquid metal. And the purpose of the liquid metal was to dramatically enhance the electrical conductivity in the traces, but also make these much more mechanically robust. And so when we transferred it to the body, or when we subjected the circuitry to bending or stretching, the liquid metal would help keep all those silver particles connected because of its ability to deform and stretch and flow with the surrounding rubber. Here's an example of a study that Mahmoud's group had led, where we assisted on exploring soft bioelectronic applications with liquid metal. So as you see on the left, we compare our printed liquid metal circuits with a variety of other soft conductive technologies, as well as gold standard technologies that are used in commercial bioelectronics. And what we found is that the liquid metal architectures tended to outperform even those gold standards. And so this has been very promising, and this is what has inspired us to adopt these technologies for this WOW project. Here's a example of a fully integrated soft electronic sticker that's capable of electromyography, so EMG monitoring of muscle activity. And here, because of the high performance of our soft electrodes, and also because of the mechanical robustness of those liquid metal interconnects, we can have very good conformity with the skin and very accurate reading of muscle activity. So in terms of future challenges that we and others need to address for further progress in this field of soft bioelectronics, one of the challenges is still due to mechanical failures. In the case of liquid metal interconnects, the failure doesn't occur at the interface between the conductor and the rubber, as you have seen before with the serpentine circuitry. Instead, in these cases, the failure tends to occur at the interface of the embedded microelectronic chip and the surrounding silicon. So that's something that we're currently facing, and there's a few solutions to that. Another area, as I mentioned, is in the field of energy harvesting and also energy storage. All the batteries that we use currently are these rigid lithium polymer batteries, or these coin cell batteries, and what we need moving forward are soft, flexible, and even stretchable batteries. So the bottom video shows a stretchable battery that we've recently created in my group that can remain functional even when stretched beyond 300% strain. Energy harvesting represents another important challenge. So the video in the top shows some recent work where we've developed a triboelectric generator using liquid metal rubber architectures that we can incorporate into a pad that we place on the kneecaps of a jogger. And as the jogger runs, that repeated contact between the skin and our liquid metal generator creates triboelectric charging, and the change in capacitance associated with that between the charge and the counter electrode results in the generation of electricity. And as we get towards the end of this video, you see that after several minutes of running, we can charge up a battery and use that to then power a wearable computing device. So in a few seconds here, you'll see that now that the battery is fully charged, we can activate this device. You can see that the digital display turns on, and we can also operate the embedded microprocessor and also onboard sensors for temperature and humidity monitoring. The top right shows some other kind of recent early effort from my lab on thermoelectric energy harvesting using these liquid metal components. Another direction or outcome of this collaborative work has been spin-off companies. So we know that, for the CMU Portugal project, entrepreneurship represents a very important aspect of these funded efforts. And so we've had not one, but two spin-off companies derived from this project. So Soft Bionics, led out of Mahmoud's lab, so based in Portugal. And then based out of Pittsburgh is Life4 Labs, which I co-founded with a postdoc who was supported on the CMU Portugal project, and who also had the opportunity to go out to Portugal to participate in the collaboration. So in terms of next steps and future work for the WOW project, we want to build on these liquid metal architectures. We actually want to move away from onboard batteries and power sources and shift towards wireless RF technologies, not just for wireless communication, but also for wireless transfer. And so both Mahmoud's group and my group have had some good preliminary success achieving that with these soft liquid metal stickers. And then another important challenge is microelectronics interfacing. And so we've made a lot of great progress through this collaboration. And most recently, on the right is an image from Mahmoud's group showing a more recent implementation where we have even more robust electrical interconnects and contact interfaces with microelectronic components. And then lastly, something that both of our groups are pursuing is studies on biocompatibility and cytotoxicity. This is not so much a factor for on-skin applications. The liquid metal is fully encapsulated within the rubber. But if we ever do want to use these materials in implants or for direct contact with internal tissue and organs, then we do have to better understand the biocompatibility of these materials. So I'd like to close by thanking both research groups, so my lab at CMU, the Soft Machines Lab, and also Mahmoud's soft and printed microelectronics, and then more generally our collaborators at ISR and Coimbra, and then the sponsors for this work. So thank you.
Thank you, Carmel. That was fascinating. I understand that you have to leave for a prior commitment, so you cannot stay for the debate, right?
That's correct. Unfortunately, I will have to. But thank you so much for giving me this opportunity to present work on our collaboration.
Oh, thank you. Thank you for a great talk. So I'll move on. But by the way, nonetheless, we will still hear more about the WOW project because Margarida is here and she will be able to tell us a little bit more about the project. So thank you again, Carmel. And let me introduce the next speaker, who is Francisca Leite. Francisca has a doctoral degree from MIT, so she's switching camps from MIT to CMU in this role. And she is here as representing the Intelligent Care Project. Francisca is with the Hospital da Luz Learning Health, which is a partner of this project. Please.
Thank you very much for the invitation. Very, very happy to be here to tell you about our project. So it's a project financed within the CMU Portugal program. And I think nowadays everybody really thinks about this healthcare world and what is the future and all the challenges that we are now encountering. And we know what these are at this point. We know that we don't have enough hospitals, we don't have enough people, we don't have enough equipment for what we need at these days. Of course, these are not normal times and these will pass, but still, this is not something from today. So we know, and we have been seeing this for quite some time now, that the healthcare spending as a percentage of GDP is growing in many, many countries, and it's actually been increasing to the double in the last 30 years in many countries. And this is mostly because of aging. Population is getting older, is getting more chronic disease, and chronic diseases are responsible for a lot of this increase. But at this point, what we see is that this probably won't be sustainable much longer. So we really need innovation in healthcare. We really need, and we are doing this, fortunately, worldwide, from universities to hospitals. We really getting new treatments, new diagnostic procedures. So there's a lot of innovation going on. The problem is that innovation is also expensive, and it's not enough. It's not enough to have a new drug, or it's not enough to have a new MR machine if people then over-abuse healthcare, or if lifestyles don't change in a way that we also are able to reduce demand on the system. And also, once people get to hospitals, it's absolutely crucial that the hospitals work extremely well. Unfortunately, again, this is very difficult because healthcare is very complex. We have disease complexity. Diseases are complex. We have more and more diseases. We have diseases of the old that we didn't even know existed before. We have diagnostic complexity. We have more and more ways to diagnose. That's great, but on the other hand, which one to use in a given disease, in a given circumstance, is also something that has to be planned and has to be done in a specific way so that we really get the best diagnostic possible and that we don't overspend. We have treatment complexity. Again, we have to follow very rigorous guidelines to make sure that we're doing the best for the patient that we have, and again, that we don't overspend in doing things that are really not needed at the time. We have workflow complexity. We have a care that is more and more multidisciplinary, involving very large teams. And if there's no communication, if teams don't work in the best way possible, then there's medical error, and there are people dying from that. And it's something that is a really great problem. It's the third cause of death in developed countries because there's just too much complexity going on. And so with all of this complexity, innovating, changing, of course, is also difficult. We hope, and there's a lot of people talking about AI, and in many sectors, and also in healthcare, there's this hope that AI will really change and help across all of the areas of healthcare. There's even those that believe that AI will replace what the doctors do in many, many different areas, and in the end, the doctors and the nurses will have time for what is actually the most important thing, which is spending time with the patients, explaining the treatments, and really empathizing with the patients. Of course, this is still kind of far in the future, but that's the hope. And also, healthcare will help, artificial intelligence helps in another way, which is basically putting us more in control, the patients, in control of our health. We have more and more apps that we can put in our phones, and that will help us diagnose or even monitor diseases, and that will also bring us a lot of data, that structured data that we don't really have available in the hospitals in a useful way sometimes. So there's a lot that AI can do for the field. We're not there yet, but there's a lot of hope that will really help to really bring healthcare to the future and to be more sustainable. And that's where our company comes up. So Learning Health is a startup inside Lucia Wood's group. It was born from the desire of becoming more than an early adopter of technology. And so we were born with a mission to shape the healthcare workforce of the future. So in the middle of all of this complexity, in the middle of what we know is a business model that really is not sustainable and needs to change, what can we do? How can we train people to understand this, to act on this, and to really innovate? And we do this putting together these three pieces: training, research, and innovation, supported by a simulation center, one of the most simulation centers in Europe. We are not alone, of course. We are in an ecosystem of innovation with other companies, with universities, and also with startups, because with this such a big challenge like healthcare, we need to really have a network approach. It's not enough to think that only hospitals will deal with this, or only the large corporates, the large pharmaceuticals, or only the governments. This is something that we all need to participate, from the patients to the startups to these corporates to the universities. So this is where we are dwelling. And in terms of research, we have all of many different interests, but mostly concentrated in 3 areas. AI, of course, human factors engineering, which is very important, and I will explain later why, and also clinical research. Always to bring value for patients, because of course that's the most important thing. So what about our project? Intelligent Care. What we aim here is to build a multimorbidity decision support tool to help doctors and patients and hospitals will deal with this condition. So what is multimorbidity? Multimorbidity is typically defined as having more than two or more chronic conditions simultaneously, which is something with aging has been, we have been seeing this growing quite a lot. So prevalence has been increasing exponentially, and nowadays people older than 65 years old, we see that at least 35% of them have at least 2 chronic diseases at the same time. And again, this complexifies care in many, many different ways. This is a very ugly graph from a very beautiful paper that basically shows that as you add more conditions, of course, treatment complexity increases, and particularly when we're dealing with systems, healthcare systems, where more and more people are being treated by specialists and not so much by the family doctors and the GPs, what we see is that we have a siloed approach to this. And so what many times happens is that different specialists will give different medications to the same symptoms sometimes without, and this will, of course, again, have some not so good outcomes. And again, there's also other problems that we really didn't know, and now with data we're starting to realize. Again, a very ugly graph from a very beautiful paper, basically showing that symptoms that are often, there are signals of heart failure, like for instance, fatigue or shortness of breath or pain, and typically a cardiologist will treat a patient for shortness of breath and for fatigue, thinking it's due to the heart failure. But the thing that we see is that most times these are actually related to comorbidities like diabetes or COPD or renal failure. And if this patient does not go to the pneumologist or the renal specialist, won't be treated for these in the right way, and will keep showing these symptoms, and at some point we might be taking too much medicine. So what do we aim to do in Intelligent Care? What we want to do first is to be able to detect multimorbidity very early on, so that we can start treating these people for the conditions they have in the right way, in a personalized way as well, because we know that there's many different types of clusters of multimorbidity. People can show heart failure with diabetes, but this can also vary depending on the lifestyle this person has, or it can show also heart failure and COPD. And so there's different profiles, and also putting together these with other variables that we can measure, we can adapt the way we treat these people so that they will go less to the hospital, so that we can, at the right time, anticipate if there's something that is going to happen, prevent an urgent visit in the middle of the night that in the end will have the patient stay in the hospital, which is something that all want to avoid. As I said, we're going to do this using data that we already collect in the hospitals, but also in a second stage, getting all of these additional data from patients, from sensors, from questionnaires that people can also fill in at home, and then we get this data about the quality of life, the physical activity, sleep patterns, life events, and all of this data we know and we hope to show that will really change the way these people are treated. So we're doing this using data, as I said, from the hospital and also home care. We're looking at structured but also unstructured data. We're trying to identify these clinical phenotypes and then build this, what we call these clinical pathways, basically for a given cluster of multimorbidity patients, what is the care that we need to do, what are all the steps that we need to go through to make sure that the patient has the best care and the less complications. To do this, we have a very strong partners from Técnico, INESC, ISR, Priberan, that will really help us in all of these projects to get this thing done. In addition to Learning Health, we also have the participation of Hospital da Luz, and this really will only be possible with a multidisciplinary team. So what, in fact, are we doing here? So again, just going through this a little bit more in detail, what we want is to identify these patients with multimorbidity. We want to know how to characterize these patients. We want to be able to build the evidence and build these clinical pathways that will allow us to treat the different patients in the way that is the best for them, and also to understand and show how these additional variables will be able to improve multimorbidity management. This is all great, and I'm absolutely sure that we'll get a lot of things from data, and we'll be able to really understand a lot more about multimorbidity. But then there's this second part of the project that is equally important, and it's where typically what we see until this point, unfortunately, with AI, is that it may work very well in the lab, but then when we go to the hospital, it fails. And it fails because hospitals are complex places, because hospitals have processes, because sometimes or oftentimes we don't really think about what's happening already and understand and plan to how we can integrate these new tools in this complex work that I showed you earlier on happens in the hospital. So it's extremely important to plan this in advance, to study what happens, to understand how it will have to change so that people will in fact profit from these AI tools. And also, there's a lot of other power dynamics going on in the hospitals. There are doctors and there's nurses, and there's power dynamics there. And these things happen, and we need to know how to address them so that amazing tools that sometimes and oftentimes we have really are used and are not just put somewhere and not thought of anymore. And so this is something that we're also dealing with in this project, is really already studying what is happening nowadays, how is the care of these patients coordinated inside of the hospital, how we identify these patients, how this clinical decision tool can really be helpful, and who is going to use it, and how it should be constructed in a way that people will, in fact, use it at the right time. And so, again, this involves a multidisciplinary team. We need to have doctors, we need to have nurses, we need to have operational and managers of the hospital involved, and they need to be very much involved. It's not just showing them something in the end. They need to be involved from the beginning, together with the human factors team that studies the user experience so that we are able to, in the end, get a tool that really is going to be used and that really will bring value to patients. Again, just acknowledge CMU Portugal program support. Very happy to be here. Thank you very much.
Thank you for a very interesting presentation. The project sounds fascinating. So our next speaker is Luís Rosado. Luís is a senior scientist at Fraunhofer, Portugal, and he is a partner in the TAMI project. TAMI stands for Transparent Artificial Medical Intelligence. And so, Luís, please tell us more about this project.
Hello, good afternoon. First of all, thank you for the invitation. It's a pleasure to share our project here in this great event. Let me just share the screen. Okay. I think you are now seeing, okay. So the TAMI project, first of all, a disclaimer. I'm here in representation of the lead promoter, First Solutions, which unfortunately could not be present, but I will try share with you their vision and their expectations for this project. TAMI stands for Transparent Artificial Medical Intelligence, and this is also a project approved by the call in co-promotion in international partnerships. And just a brief outline of the presentation. I will start with the motivation of the project. What is the problem and the opportunities that emerge by tackling this problem? Also, what are the objectives of the project? What we are proposing as a solution for this problem, and also briefly present the team and the timeline for the project. And then in the end, also address what are the expected results, not only from the R&D perspective, but also what commercial opportunities we envision with the outcomes of this project. So let me start with the brief contextualization. As you all are aware, the current rise of artificial intelligence has brought exciting advances in a wide range of applications. Medicine is one of them. And this was greatly boosted by three main factors. The fact that there's right now large and diverse data sets available. We also have access to improved algorithms, and we have also new levels of computing power. But despite this spectacular success of AI recently, there are still huge challenges, and the previous presentation also highlighted that. And in particular, there are areas of public concern that we consider that are constraining a wider use of these AI systems. And one particular example for these concerns and these needs is the European Commission report that was released last year, which is related with a comprehensive European industrial policy on artificial intelligence. And in this report, it's clearly stated that AI needs to be ethical by design. So characteristics such as transparency and explainability should be embedded in the development of these AI systems. So in other words, the problem that we are currently facing and focusing on for instance, in the imaging domain. So we are right now, some models are achieving very good results. Some of them even surpasses the humans in specific tasks, but many of them are like black boxes. So we don't know the internal logic and inner workings of these models. They are hidden to the user. So this is a serious disadvantage because prevent us as humans to verify, to interpret, and to understand how particular decisions are made by these AI systems. This was also one of the main motivational factors for the emergence of a new field of study, which is called explainable artificial intelligence. This is one of the main building blocks of this project. And what this new field of study tries is to make a shift towards a more transparent and interpretable AI development. So if we focus on specifically on the usage on AI in medicine, there are a lot of challenges, and one of them is the fact that decisions in medicine are very complex and usually uses diverse data. So we can have different types of data to take a unique relevant decision, from images, time series, text, and in order to give this diverse data in a standardized way to the machine learning algorithms, we need to tackle problems in terms of mapping where is this data, how are we going to fuse this data, how are we going to integrate this data in order to standardize the inputs of these models. But besides that, and if we look to the clinical domains that use images, we can clearly see that right now there's an inherent tension between performance and explainability. So right now, the best performing models in a wide range of use cases are based on approaches called deep learning. And right now, this is one approach in AI that is the least transparent because it's not clearly understandable for the user how a particular decision was made. And in the opposite, the approach, more conventional machine learning approach that are more clear and transparent, right now are not achieving the performance of these deep learning approaches. So we know that in medicine, high performance is a must, so it's almost mandatory. But at the same time, we also need to enhance trust and give the basis to certification of these approaches by knowing how the inner workings and their reasoning behind the decision. So we need to balance between this high performance but also transparency and explainability. So one of the main challenges in this project is to try to achieve these two requirements at the same time. So we want to develop approaches that are high performing in the medical domain, but at the same time, these outputs can also be understood and cross-examined by the users. Or in other words, what we aim to achieve is not only develop algorithms in specific areas that don't only give the decision, but also give an explanation, a reasoning for this particular decision. So one of the objectives of this project is, in fact, develop this next generation of AI models that have embedded these requirements in terms of interpretability and explainability. And it's very clear for us that there's not one solution fits all. So we cannot achieve a structure of an explanation for a specific decision that fits all the use cases. This must be dynamic and must be adaptable to specific use cases. First, because most of the times we are talking about multimodal problems, so we have sources of data from different types: images, text, time series. And second, because we have different users with different profiles. So for instance, if you have a user that only works in the image domain, let's say a microscopist, probably explanations in the image domain will be the way to go. For instance, with approaches like highlighting in the image which areas contributed most for this decision, what are the characteristics on this particular image that most contributed to this decision. But at the same time, if you have use cases where also the electronic health records are used, we need to adapt to this health character and also show how the multimodal decision was made. So what are the key aspects in the electronic health records? For instance, family history coupled with the result of a specific exam and the presence of specific structures in the image that contributed to this automatic decision of the AI system. Second, what we realized while exploring this idea is there are not standard and clear ways to evaluate the interpretability of AI models. So what we also aim to achieve is quantitative methods that we can objectively use to assess and compare different types of explanations. So if you have a library of different types of explanations that we can deliver to a specific decision, we need to understand which is the type of explanation that best suits a specific profile of the end user. And this, what we try to do is bridging the gap between these raw measurements in terms of interpretability with also user-centric measures. And here we count with the contribution also with our human-centered design team, which is going to have an active involvement with health characters to shape these evaluation metrics. And third, we also believe that doing these methods is not enough if you want something that can be effectively used in the clinical practice. And so the way we show these decisions and these explanations need to be adapted to the clinical practice. So these outcomes cannot be an overhead to the already very exhaustive work that the healthcare actors do. So on the other side, these tools need to be as intuitive and as transparent as possible, so it can be really easily embedded in the clinical practice. So having these different approaches, I will say more ground-based research about these generic methods. We, in this project, also aim to apply them in specific clinical domains. And we are talking about 4 different imagological domains, which are the cervical cytology, cervical colposcopy, glaucoma, and chest X-ray. And with this, build a platform that deliver these functionalities. So here I have a diagram that represents the architecture of our solution. So basically, we have these horizontal layers where we have these generic methods that we aim to develop. The first one more related with the decision. So it's the layer where we develop the models that actually give decisions that aim to support the clinical practice. And we will receive as input image data and also electronic health records. On the second layer, we have this translational layer, which also tries to generate the explanations for these particular decisions of the layer below. And then a third layer, which is used to evaluate which are the best type of explanation for a specific profile in the clinical practice. And a fourth layer, the top layer, which is the interface layer, where we are going to develop the support tools and demonstrators. And here we have these 4 clinical domains I referred previously that, as you can see, goes transversely being fed by the different layers developed, so we can demonstrate the usage of this generic approach in different use cases. And of course, these are going to be changed both for clinical inputs, but also from market inputs. So in terms of the team, the lead promoter is First Solutions, Sistemas de Informação. First is currently the main supplier of screening measurement software for National Healthcare Service in Portugal. So they have actually in usage different information systems that are supporting screening programs such as the cervical cancer and the diabetic retinopathy programs, screening programs. As co-promoters, we have Fraunhofer Portugal, which is a team led by me, Inestec, a team led by Professor Jaime Cardoso and Professor Aurelio Campilho, Carnegie Mellon University, of course, led by Professor Azim Smeiljic, and also Administração Regional de Saúde do Norte, which is going to be very important in the clinical domain, and also to make the bridge with our clinical partners. So we also have clinical partners. Some of them are subcontracted. And this is a key aspect because we need this commitment from the clinical partners to successfully execute this project. And they will work, help us in the clinical guidance, also in the data collection and annotation, and then in the end, in the field trials and evolution of the solutions. So I will not go into detail about the timeline. So just to let you know, it's a 3-year project started in April. In blue, we have here a lot of R&D tasks that are going to tackle these problems I've been talking, but it's also worth mentioning that we have a very important work package related with the field trials. So we really want to go to the field and try these approaches and see if it actually brings a benefit for the clinical practice. In terms of the expected results, from the R&D perspective, it's directly related with these approaches that we want to develop related with generating explanations to support decisions, multimodal explanations, and be very customizable and adaptable to a specific use case and a profile within this use case that is going to use it. A very quick example in the cervical cytology, we have the cytotechnicians that work just in the microscope. So here we can focus on explanations only on the image domain, but then we have the medical specialists that also use the electronic health records, and then we can have more complex explanations and more complex models that also use this text information to take the decision. Then we want to develop these methods to assess and select the most suitable explanation for each specific use cases and profile, and then have these novel visualizations methods to present the decisions and the explanations without overheads for the clinical practice, but actually turning the process more efficient. So then we want to merge all these contributions in computer-aided diagnosis tools in these different use cases. Here on the right, we have some illustrative images from cervical cytology, cervical colposcopy, glaucoma analysis, and also chest X-rays. Just a quick note about this version of the chest X-rays. Right now, we are focusing on using X-ray images from positive or suspected COVID-19 suspects, because there were released some public data sets on this aspect. And so the team from INESTEP is actually working on these data sets to see if we can develop automated tools to predict and understand the infection. To finalize, in terms of commercial outcomes, First Solution already has these information systems that are used on the screening program. So we aim to integrate these computer-aided diagnostic tools in this information system, and also provide not only the decision, but also the explanations, and also take this opportunity to evolve the system and bringing new capabilities in terms of annotation and visualization. Besides the information systems for the screening programs, we also envision a more broad platform being used for scientific, academic, and commercial purpose, where also we are going to give access to these computer-aided diagnosis tools for healthcare workers outside the screening program, and also use this platform to provide filter and anonymized data sets for researchers that can be used to increase the knowledge base for academic purposes. And basically that's it I have to present. Thank you very much for your attention.
Thank you, Luis. Thank you. This also sounds like a very interesting and impactful project. And our last speaker is Margarida Neri from Glint, and she's representing the WOW project, which has a very long acronym, but is related to devising smart beds for hospital patients. And so please, the floor is yours.
Well, hello everyone. I'm very glad to be here. Thanks for the invitation. Well, today I'm going to be talking about wireless patient biomonitoring and smart IoT system connected to patient's bed at the hospital or at home. Well, this seems a lot of things and it's very extensive, but in few words, what I'm going to talk about is about wireless biomonitoring of patients. Well, let's see if I can do this okay. Yeah. So first of all, I'm just going to present myself. I work at Glint, and Glint's business is mainly in the health area, and we work with health providers and with pharmacies. Our two biggest markets are Portugal and Spain. And we are a technology company, and we work focused on the citizen's journey, focusing on health management besides the disease management. But our main focus is on health management. That's why we are now a part of this consortium that's working in WOW. And along with Glint, we have ISR from Coimbra, and they are an important part in this project because they are printing the stretchable and electronic skin devices, and their expertise is helping us with the IoT and the AI modules. For University of Coimbra, we're having the material science expertise, and the hospitals of Coimbra, well, they are also widely known, and they are one of the biggest healthcare centers in Portugal. And they come to the project with a pilot and with the patients that we're going to monitor. For Carnegie Mellon University, well, Carmel has already spoken, and we have his contribution with biosensors. So, for these wireless biomonitoring patients, well, we work on the patient's journey, and we want to improve the quality of life for everyone in the society. And when we are using this wireless biomonitoring, what we want is for the patients to have the best comfort there is. So make sure that they are unfettered from all the wires that you have on a hospital bed. And make sure that they are autonomous, they can get up, they can go from one side to the other, they just can give a small walk around the bed. And also to power for the domiciliary hospitalization. So we don't want patients that don't have to be in the hospital, in the hospital beds. We want them to have the best care possible, and the best care can also, and most of the times, is at home, where they are better, they are with their families, and if we can promote this kind of approach, well, it's better for everyone. It's also it also implies some cost reduction because we are not having all the hospital beds occupied. So if we're removing the patients from the hospitals, we'll have more ways to treat other patients. And also for the biostickers, the way they are being assembled is using materials that can also be more cheap and than the ones that we are now used in hospitals. For all stakeholders, well, we have data, and data is power, so if we can have this data, then we can have everyone informed and we can have better policies. So I'm just going to share the project components. So for the biomonitoring stickers, they've already been mentioned by Carmel, and he knows a lot more than I do on this area. But mainly, we're going to have biomonitoring stickers that are going to measure the vital signs like heart rate, temperature, ECG. We're going to see some motion and to detect some motion from the patients. And then in a highly new approach and experimental approach, we're also going to try to find some of the emotions from of the patients using the galvanic skin response for emotional computing. Well, the information that's being collected from the stickers is going to be collected in a smart box. That's going to be, I don't have a pointer, but if you see for each patient, he's going to have the sensors, and then you have the smart box in each bed. So each patient has one bed with a smart box. That smart box is going to collect the information, and then all the information goes to a smart gateway. And in this smart gateway, we're going to have an interface between the smart bed IoT and the hospital solution. In this case, it's Global Care that's going to be showing the information to the doctors. Also, an experimental and a breakthrough that we want to have with this project, like Carmel said before, it's the harvesting and the storing of the energy. Because one of the problems we can have is that all these wireless biomonitoring stickers have batteries, and we want to make them live longer. And for that, we need to power them. And we're going to try to find the SmartBox solution that can give this, also can help with this challenge. So for the patient evaluation, we're going to have Global Care, we're going to collect all the information, and then for doctors and nurses can see how the patient is doing, if he's at home or if he's in the hospital. So next, I'm going to show a video for all of you that have assisted to Carmel's presentation. You just can check your emails now, because for the next 2 minutes, I'm going to show you why we call this WOW. Well, I must confess, I never get tired of watching this video. When it comes to our project, for the WOW project, the biomonitoring stickers, I'm showing some samples of what has already been done by the Institute of Systems and Robotics in Coimbra. And the biostickers that we're going to have in this project will be similar to these ones, to collect the vital signs and the other signs that I've just mentioned earlier. So for now, and what we've done since April till now in this project, we've already selected the pilot for the project. It's going to be in the University of Coimbra, our partner, and it's going to be the orthogeriatrics service that's going to work with us in this project. We are now defining the user requirements, just to make sure that when we go to the pilot stage at the end of the project and we're going to have the biomonitoring stickers in the patients and everything assembled, we are going to get information that's useful for the clinic, for clinical evaluation, so for doctors and for nurses to work with. One thing that I didn't mention is that we're going to have a pilot with 5 people. We are going to work with them in the hospitals, in the hospital service, so in the hospital stay, but we also want to bring them out and to the home of the patients, and to make sure that they are still going to be monitored. So along with defining the user requirements, we are also doing the definition of the system's architecture, because we need to have the smart beds working well. So we are also working on this interface. So from the biostickers to the smart box to the gateway, and then to Global Care to present the information. The designing of the biostickers and selecting of the sensors is also a work that we are doing now. So for the expected impact, and like Carmel said before, we're going to demonstrate with this project for the first time ever the integration of biomonitoring skin into a professional health information system. So we really want that the data that we're going to collect is going to be used, and it's safe to be used, it's credible to be used by doctors, by nurses, and that they can do medical calls based on this information. We are also, so when we come to the positioning and commercialization channels, well, the first ones will be hospitals, but we will also want to take them to home care and to pharmacies that are near population. And so it also makes sense. And we can't skip talking about a pandemic situation like the one we're living now. I'm sure that for these biomonitoring stickers that we're talking about, they won't be useful for COVID, because the vaccine will come sooner than the project will end. But for a situation like the one that we're having nowadays, and that we don't want a lot of people in the hospitals, we want to make sure that people are safe and that they are being correctly monitored outside the hospital. Well, these kinds of situations will help us to monitor people that don't need to come to the hospital, that they are okay at home, they are safer at home, but still have a quality in their health and in the healthcare that's being provided. So I want to thank you, everyone. If you want to know more about us, you can check our website, and happy to be here.
Thank you, Margarida. We have time for a very short discussion, about 5 minutes only. So I'm not sure if I'm probably only going to be able to ask one round of questions. And I would like to ask you the following. As academics, one of the main concerns we have is if we are providing the right training to our students and to our doctoral students in particular, so that they can subsequently move to very good jobs, a few of them in academia, but more and more of them in industry. And in fact, my students, the students from my group nowadays get more jobs in industry than in academia. I guess my question is, do you see these projects as contributing for creating the conditions to have those sorts of positions for PhD students to move on to companies and do highly innovative work? And more generally, what is the role of PhD graduates in the innovation that you are doing in your companies, and how do you see that role evolving? Maybe you can start, Francisco.
Well, I can tell you that our project, for instance, would not happen if there were not 2 PhD people in our company. So that's the main reason why we were able to get this project going. So that's extremely important. We do have a different way to think than most people in companies, and that's very valuable, and the way we can structure information is really helpful. It's not only particular to PhDs, of course not, but it definitely helps. And specifically when we go to these kind of projects which are complex, and you really need to understand, to be able to have a consortium that works, we need to be able to understand what the people in the universities and in the academic institutions are saying. If you don't really have the training, it gets very hard to do that. We have been, that's one of the things and one of the difficulties in this project at this point is that it's really the hiring, because we were looking for PhD people to help us in this, and we finally were able to hire a person at this point, but it was extremely difficult. There's not a lot of them, and not a lot of good ones. And the first few interviews that we were only able to interview people that were just ending the undergraduate, so not really a lot of PhDs that we were able to hire, also because the market is global at this point. But it definitely helps, and I really cannot see these projects going on in industry without having PhDs there. That's absolutely impossible to do. What happens then is that they become very university-driven and not so much company-driven. And I really think, at least in healthcare, it doesn't really work. So I definitely think we need to have more PhDs working in the companies.
Am I? Oh, it's on. Okay. So yeah, I agree with what has been said. And for our companies, we know that if we want to have a breakthrough, if we want to do something out of the box, well, yes, we need to work with investigation with the universities. For this project, we have PhDs not only for ISR and for all the other parts of the consortium, but it's important because if you want to do the wow things and the breakthroughs, you need to have the curiosity and from PhD students and from PhDs, and also you have to have a balance, and then for the companies to know what's good for the market and what has to wait some time to go to the market. So I think it's a good symbiosis that we can have here.
Now for Luigi, if Luigi is still there, Fraunhofer is an institution that bridges academia and industry. How do you see these projects helping in establishing that bridge?
Yeah, it's really important because in our philosophy of research at Fraunhofer Portugal, we already have this matrix. So we try to do research really close to the companies and really close to the applicability. And we always try to have these projects to create more competences in our team. Because if you want, I completely agree with the previous suggestions, because if you want to deploy something in the clinical practice, we need really strong competences, very maturity in terms of our skills, and we always try to bring to these projects really strong teams, and at the same time also include persons of the team that can evolve also to a PhD. So doing the PhD during the project, and we are going to try also to do this in the TAMI project.
And so as a last question, I would like to ask you, how do you see the role of Carnegie Mellon in this partnership? What is the value added by having a world-leading university in this area working with you?
I can start now. Well, for us and for WOW, it's the biostickers. We know that we couldn't achieve, or we won't achieve what we want. It's the monitoring at home if we don't have the expertise, if we don't have Carnegie Mellon, if we don't have Carmel and all his team working with this breakthrough. So for us, I may say that we wouldn't have a project for that. And this project, I really believe that it's going to be very important, and that it's going to have in the society the ability to let people stay at home, be cared at home, focus on health, not just on the disease, because we know that if people stay longer times in hospitals, the depressions and some other not so good diseases can come. And for this kind of project and to make sure that we're going to be well succeeded, well, I think that Carnegie Mellon and these biostickers, this technology is very important.
Yeah. And Franziska?
Yeah, again, Carnegie Mellon in our case, as we have people there with the particular expertise to design clinical pathways that really don't exist in Portugal yet. So of course, in just that sense, it's very useful and important to have them on board. But overall, it's always important to have really smart people put together in discussing this, in this case, in virtual rooms. So Carnegie Mellon people, of course, super important to have here, also bring up the international perspective, which is quite important because in healthcare, there's a lot of variability if you move from countries to countries from different healthcare systems. So that's already just in itself very important. Of course, it's always also extremely important to have people from Técnico and all of the Portuguese institutions that we have on board. Again, putting smart people together, it's always the best way to go in these very complex problems.
And Luis, to conclude, how do you see the involvement of Carnegie Mellon?
Yeah, it's also very, very important because when we are talking about projects, we have such disruptive ideas and concepts like explainable AI, having different perspectives from different contexts is very important, and this will require a lot of discussions and brainstorming and explore different paths, and so a very strong team is very important. And also we know that and Carnegie Mellon, the type of research they do probably have a more focus on how to deploy this in the clinical practice. So we see in the Carmel presentation when we talk about the spin-offs and how to shape what we are already researching to be effectively used in practice. So I hope that this collaboration with Professor Azim also contributing that perspective.
Okay, thank you. So this concludes our session. I would like to once again thank all of our speakers. I would like also to thank the audience and hope that you enjoyed the session. Thank you.